Hey, it's Ben from Playwell. So I was expecting one of my students, Lucas, to come by again today to show us one of his models, but I think he might be running a little bit late. So Lucas, thanks for showing up again.
Sorry I was late.
You know, a little bit late, but that was quite an entrance, but thanks for joining us. So you brought another one of your Star Wars models to show us, so
Yes.
you want to explain what you brought?
So this is the Imperial Assault Carrier, and it has two cool mechanisms that I wanted to share today.
So Lucas, now let's take a closer look at the first mechanism that you wanted to share with us.
So our first mechanism is going to be this crank, which turns these two turrets. What's funny about it is that the crank is pointing this way, and the turrets are pointing this way.
And with this model, all the mechanism is kind of encased. It's hard to see. So again, Lucas and I have worked on a few models that can demonstrate some of the workings and how that mechanism can actually function.
Okay, so our first mechanism, we have a simple little design here. As you can see, when I'm turning this gear, it's turning this axle right here.
How does it do that? What kind of special gear do you have to use to make it turn an angle like that?
I use a crown gear. So a crown gear is this.
What's special about a crown gear? How does it
A crown
turn
gear
an
is
angle?
special because its teeth are pointed upward instead of just out.
Okay. And what does that allow you to do?
I put this back on, and what's happening is the teeth are going into the teeth of this gear. The teeth of the crown gear are going into the teeth of this gear just like a regular gear. So what's happening is when I turn this gear, it turns the crown gear, which turns the axle.
So those axles are actually perpendicular to
Yes.
each other. How many degrees between those two axles?
90.
90 degrees.
So this model is going to be using beveled gears.
So how are those different from crown gears? What do the teeth look like on bevel gears?
Bevel gears, the teeth are kind of like circled.
Okay, they're a little
kind of
rounded.
like a little bit rounded. And also, they're pointing kind of like a crown gear,
Okay.
but they're still attached to the gear.
So those two are both bevel gears, so those also can mesh at a 90-degree angle?
Yes, they
So
can.
show us what are you going to turn? You're going to turn this one here
I can turn
like the
either
model?
one and
And then they
either
spin.
axle turns. So, our second mechanism is a little bit crazy. So we're going to pick it up,
Whoa.
and we have these buttons on the back of the wing, and when you press one, it drops the TIE fighter.
Oh no. So how does that actually work then, Lucas? Can you show the bottom of it? What's actually happening down there?
So what's happening is when I press the button, this little lever is moving a little away from this little axle, and this is hooked on to the axle with a little hole.
And so when you release that lever, gravity just pulls that TIE fighter right down and it drops.
Yep.
Awesome. So again, let's take a closer look at another mechanism that we built that will demonstrate that a little bit clearer. So this right here, can you move it around? I remember you mentioned when you showed us the original model, you mentioned the word lever. Can you explain what a lever is?
A lever is an arm that can basically pivot, like this.
Okay, so what are the parts of a lever?
The three parts of a lever are in the middle, the fulcrum. That's where it moves.
And the fulcrum doesn't always have to be in the middle, but in this
No, it
case
does not.
it is. That's where it bends, right?
This back part is called the effort. The effort moves the load, which is on the bottom,
So by pushing the effort one direction, which way does your load go?
the other direction.
In this kind of lever, that's how it works.
It goes the opposite.
Now, in the model that you did, it had an actual release. So show us what we're going to add. We're going to slide on that axle a studless beam, just a little beam. But why does this not work?
Because if I let go, there's no effort.
Okay, there's
So
nothing
there is
holding it in
no
place.
effort except my hand holding it in place. What we need is a rubber band. We're going to attach the rubber band to these two pins,
And
just like this.
And what that does, you can see that's actually now the effort is here. This is where the lever is being pulled instead of at the top. And so now that keeps it snapped in. So now show us what happens when we slide the little piece up onto the axle.
So we slide it up, and now I'm not holding the lever and it's staying in place.
So how
Now
would you
all I have
release
to
it?
do is push this, and it releases, just like the set.
So Lucas, thank you so much for coming by today and
You're
sharing
welcome.
this awesome model with us and for helping build some of these little mechanisms so we can hopefully teach people some of the engineering behind this model.
If you build any of these or any other cool creations, please share them with Playwell. We always want to see your creations.
Definitely. So we hope you learned something today. Thank you so much for watching. Remember to play well, and we'll see you next time. Awesome. Well, let's do it one more time.
Yeah, I think that was a little bit bad.
A little bit booky.
But I think I got it better.
That was a really good one, and I messed it up. I messed it up.
Ben! You're a bad man.
Horrible, horrible, horrible. Okay, last time. This is gonna be perfect.
Okay.
Alright, it's not new.
It's
okay.
not. Oh, come on, Ben! You said this would be our last
one.
time.
This is it. Again, in short, sharing it up. Okay. I'm gonna have to do a bloopers reel at some point.